how do you graph a linear relationship? So think linear, that means it's going to be a line, but all of our relationships come from word problems. So how do you graph a linear word problem? So let's review. What does a line show? A line shows every pair of numbers in a relationship. What is a line made of? Points. And what does a point represent? A pair of numbers. Let's take a look at an example here. Farmer Hi collected 3 mimstoons every day. She started with 99 of them. So we're looking here to identify our rate of change. So what's changing? Well, the changing is how many mimstoons she has, and it's changing by 3 every day. So our rate of change is 3. Our starting amount is 99. We can now write an equation for the total mimstoons y after x days. Remember, the format for this equation is y equals mx plus b. So our equation is going to be y equals 3x plus 99. Using this equation, we can fill in the table by substituting in values for x and then evaluating. So if x is 0, we have 3 times 0, which is 0, plus 99, which is 99. If we have 1 in for x, we will get 3 plus 199, or 102, 105, and then notice we have 7 here, so y equals 3 times 7 plus 99. 3 times 7 is 21, and 21 plus 99 is 120. So our y value when x is 7 is 120. We can graph this relationship. So far we have identified the rates of change and the starting amounts. We've filled in tables, we've written equations, we've even determined the value of the output when we were asked to a specific input. Now we're going to add to that and we're going to graph. So let's take a look at how to do that. So with this graph, we remember that x days. So our x value, or our x-axis, is going to have the label of days. The y-axis is mimstoons. So we'll have mimstoons. Notice that mimstoons is a very large number, right? We have 120. So we're not going to be able to go up by ones on our x or on our y-axis, even though we could on our x-axis, because the x-axis is increasing by ones. So here we're going to use a y value and we're going to scale it for 10. So each line is going to represent going up by 10. And then we can plot our points. So at 0, and x is 0, where we've had 0 days pass, we are at 99. It's very close to 100. After 1 day, we are at 102. 2 days, 105. 7 days, 120. We can graph this and have a line. This isn't really a line though, it's a ray. Why is it a ray? Because a line goes on forever and ever in both directions. We have an endpoint. So one endpoint and then going off in one direction forever and ever, we have a ray. And we don't really need the 2 numbers in between, we just need that last number, so we only need 2 points to graph a ray. We need the starting point and then some other point that it passes through. Let's look at another example. Farmer Friend started with 62 Boondins on her farm. Every month, she collected 8 more of them. So because she's collecting 8 more each month, our rate of change is 8. Our starting amount is 62. Write a rule for total Boondins Y after X months. Remember, this follows the Y equals mx plus b format. So Y equals 8x plus 62. How many Boondins will she have after 9 months? So if we have Y equals 8 times 9, because months is our X, plus 62, so we get Y equals 72 plus 62, or 134. X is our months, so we'll label our x-axis months. Our y-axis is Boondins. And we can make our table to see how this is going to work. So our x values when we had 0, 62, and then after 9 months, so our x value was 9, we had 134. So here are our points. We don't even need the bottom 2. We don't need 4 points, we just need 2 points in order to graph. So if we look at our x values, we can continue up our x-axis by 1s, but for our y-axis, we have 134. 1s is not going to work for us. Remember on the previous example, 120 reached almost our last line, and we went up by 10s. So this time, let's go up by 20s. Again, we're going to graph 0, 62, and then we're going to graph 934, and then our ray goes through them. So this is how we graph for these problems. And again, we have a ray. So let's take a look at how we're going to graph this in Get More Math, and we're going to follow some steps here. So the first thing we need to do is click on the x-axis. Okay, and that's going to ask us for an x label, and there you want to either type or select our units, our months. And we're going to count by 1s there. And then our y-axis, our units here is Boondins. We're going to count by 20. We already graphed this. I just want you to see how to do it and Get More Math now. So then we're going to go up to the select, and we're going to drop down to the ray. And this is very important. So we're going to click on the ray at 0, 62. So right there is 0, 62, and we're going to click, left click, and we're going to drag, which means we're going to keep that held down. So we're going to drag it over, and we're going to keep going until we get to 9, and then we're going to keep going until we get up. And don't let go, because we're not there yet. We need to go up to 134, which is about right there, and now we can let go. So we want to click and then drag to where we want our second point, and then let go when it's where we want it. Okay. If, however, we make a mistake, we just click the trash can button. Start over with your ray. So here we'll take a look at one more example. Farmer Double added 5 stems every hour. She started with 43 of them. How many stems will she have after 3 hours? So here we can come up with an equation. We know that our rate of change is 5, and our starting amount is 43. So our equation is y equals 5x plus 43. We are concerned with how many stems she has after 3 hours. So we'll substitute 3 in for x. 5 times 3 is 15, plus 43 gives us 58. So we have our points of 0, 43, and 3, 58. Our x-axis is hours. Our y-axis is stems. If we look for our x, we can go up by 1s for those. But for our y's, we should probably go up by 5s. 5s is going to be good. Okay, so we need to graph 0, 43, and then we graph 3, 58. Now remember, if you're graphing this in Get More Math, you're clicking at 0, 43, and then dragging your mouse all the way to 3, 58. And then we have our ray.